Hi everybody, it's Bailey Brown again, and today we're going to be talking about 6 different questions, including a question about the divisibility test, casting out nines, the greatest common divisor, the least common multiple, revolutions, and the magic square. So I'm going to go ahead and screen share. Okay. Alright, so we've got Module 3, Chapter 4, Number Theory, and Chapter 5, Integers. So we've got question 1, divisibility. We're going to talk about the divisibility rules for several different numbers. The divisibility test for 2 is that it must end in an even digit. So we're going to be looking at 684, 2064, 51,051, 644, 4,090, 2,676,740, 50,250,528. So 684 is divisible by 2 because the last digit in the number is 4, which is an even number. Same with 2064, the last digit is a 4, which is an even number. Now in 51,051, the last digit is a 1, and that's not an even number, so it's not going to be divisible by 2. In the next one, a 0 is the last digit, and it is divisible by 2. Same for the next number. And for the last one, the last digit in the number is 8, which is divisible by 2 because it is an even digit. The divisibility test for 4 is that the sum of the last 2 digits must be divisible by 4. So in 684, the last 2 digits added up is going to equal 12. So 12 is divisible by 4, so the answer to that is going to be yes. So we've got the answers displayed here for if the last 2 digits, when added up, are divisible by 4, then those are the answers that we're going to get. Now, the divisibility test for 5 is that the whole number must end in a 5 or a 0. So out of these set of numbers, the only ones that are going to be divisible by 5 are going to be 644,490 and 2,676,740. Next, we have the divisibility test for 6, and the requirements for this is that it must pass the divisibility test for 2 and 3. So we're going to be down here on this one, and so we're going to look at the 684, and we're going to go back up, and we're going to look at the first line for 684, and the answer to that one is a yes. And for 3, which is going to be on the next slide, it's going to show us what all is divisible by 3 and what the divisibility test is for it. But I'll go ahead and tell y'all now. 684 is divisible by 6. 2064 is divisible by 6. 51,051 is not divisible by 6 because if you look up top, it has failed the divisibility test for 2. 644,490 passes, and 2,676,740 does not. But if we look up the divisibility test for 2, it passed that one, so it must not have passed the divisibility test for 3. Moving on to 50,250,528, it also passes this one, and if we see up top, it passed the divisibility test for 2, and for it to be a yes, it must have also passed the divisibility test for 3. Okay, and the divisibility test for 10 is that the number must end in a 0. So out of these sets of numbers, the only 2 numbers that are going to end in 0 are going to be 644,490 and 2,676,740. Alright, so now we're going to look at the divisibility test for 3. So the requirements for this is that the sum of the digits must be divisible by 3. And so what that means is that you're going to be able to add up every number in the set of numbers, and that should be divisible by 3. So in the first section, we've got 684. So 6 plus 8 plus 4 is 18, and 18 divided by 3 is 6. So the answer to that one is going to be yes. we've got 2,064, and 2 plus 0 plus 6 plus 4 is 12. So again, 12 divided by 3 is 4, so we get a yes on that one. 51,051, so we've got 5 plus 1 plus 0 plus 5 plus 1. We got 12. The same as before, 12 divided by 3 is 4. So far we've got all yeses. Next, we have 644,490. So 6 plus 4 plus 4 plus 4 plus 9 plus 0 plus 20 equals 27. So 27 divided by 3 is 9, which gives us a correct answer of yes. All right. And so next we have 2,676,740. So when you add all of these numbers up together, you get 32. And 32 divided by 3 is 10.7. So we just want a solid number. We don't want any decimal points after the whole number. So that one's going to be a no. And the next set of numbers is 50,250,528. So when all those numbers are added up together, we get 27. And 27 divided by 3 is 9. So we got a yes on that one as well. The divisibility test for 7. The qualifications are that you have to be able to take the last digit of the number, double it, and subtract that number from the rest of the problem. Okay, so in the first problem, we've got 684. So the last digit is 4, and we're going to multiply it times 2 to give us 8. So we've got the beginning 2 digits are going to be 68. So we're going to subtract that number that we got from the 4 times 2. We're going to do 68 minus 8, which gives us 60. And when you divide that by 7, you're going to get a decimal, which that's not what we're wanting. We're wanting a whole number. So that one's going to be a no. So we're going to do the same thing with all of the numbers. We got 684 is not divisible. 2,064 is not divisible by 7. 51,051 is. 644,490 is divisible by 7. 2,676,740 is not divisible by 7. And then we've got 50,250,528, which is also not divisible by 7. The divisibility test for 8. The last 3 digits must be divisible by 8. So in the first problem, 684, that's pretty simple. We're just going to divide it by 8, and it doesn't come out as a whole number. So that one's going to be a no. But say we look at this fourth problem, we've got 644,490. So we're going to take it apart, and we're just going to look at the last 3 digits, the 490, and we're going to see if that's divisible by 8. And it's not, because it also gives us a decimal. So we've got 2 answers in here that are going to be yes, and that's going to be to 2,064 and 50,250,528. Okay, and the divisibility test for 9. This one's a lot like 3. It's that the sum of all of the digits have to be divisible by 9. So you're just going to add up every digit in the number. Say, for instance, we look at the third one. We're going to do 5 plus 1 plus 0 plus 5 plus 1, which is going to give us 12. We're going to do the 12 divided by 9, which is going to give us a decimal. So that one's not going to work. And you're going to do the same test for each one of these numbers. We've got the answers right there. All right, the divisibility test for 11. We're going to look at the alternating sum of the digits to see if it's divisible by 11. And if that's divisible by 11, then the original number will be also. Okay, so in 684, we're going to do 6 minus 8 plus 4. So we're going to subtract that second number in the problem and add that last one. So that's going to give us a total of 2. And then 2 divided by 11 is going to be 0.18. So that one's not going to be divisible by 11. Let's look at one that will be. We're going to look at 51,051. So you've got 5 minus 1 plus 0 minus 5 plus 1. That's going to give us a total of 0. And 0 divided by 11 is 0, which is a whole number, so we're going to say that it is divisible by 11. Right, we've got the answers lit up right there. And this is the whole chart with all of the numbers that we just did in the divisibility test. So that's all right there. All right, we're going to move on to question 2, the processes of 9 or casting out 9s. Okay, so we're going to look at section A first. They've got 416 plus 7,490 plus 69,844 equals 112,790. So you can do this the original way, and you can add it up as I've done right here in the left-hand side in the red box. Just 400, you're going to set it up how the problem says it. And then down at the bottom, we've got 416. So 4 plus 1 plus 6 is 11. So we're going to simplify that 11 because we want a single-digit number. So we're going to do 1 plus 1 to give us a 2. Okay, keep that in mind. So next for the 7,490, we're going to add 7 plus 4 plus 9 plus 0, which is going to give us 20. We want a single number, okay? So the 2 plus 0 is 2. And you're going to do the same with the 69,844, which that's going to give us a 4 as it's a single number. So when we add all of these numbers together, we've got 2 plus 2 plus 4, which is going to give us a total. I've got this wrong here. It should say 8. Anyways, so we'll say 8. And then you're going to take that total that we had to begin with of 112,790. So we're going to break that apart as well and add each single digit in the number. So we've got the 1 plus 1 plus 2 plus 7 plus 9 plus 0, which is going to give us 20. We want a single digit, remind you. So we're going to add the 2 plus the 0, which is going to give us 2. And so these answers that we got, they're not equal to each other. The 8 that we should have had at the bottom is not going to be equal to the 2, so we know that this problem is not right. We know that we messed up somewhere. All right, and if you look over to the right side, the part where it's talking about, it says casting out 9s, it's a simpler way to do it, kind of, is that anything in each row that is a 9 or adds up to be 9, you're just going to cross it out. You're not going to do anything with it. You're just going to pretend it doesn't exist. So the 416, we're not going to do anything with that because, I mean, it's the same thing as before. So we're going to end up with a total of 2, again, at the bottom. So in 7,490, we're going to just take out that 9, pretend it never existed. Okay, and so then we've got 740. So when you add up those digits, you're going to get 11, and 1 plus 1 is 2. So that's giving you the same answer without using the 9 as it did with that 9, because on each side you got 2 as your single digit answer. And on the last one, that's 69,844, you're going to do the same thing. You're going to take out that 9, and so we've got 6,844. So when we add all of this up, the 6 plus 8 plus 4 plus 4, we get 22. And 2 plus 2 is 4. So we end up with the same thing as we did before, the 2 plus 2 plus 4, which is going to give us 8 again. And then after that, we're going to take what it says that it equals, and we're going to, the 112,790. We're going to take out that 9. Just pretend that it doesn't exist. And you also could take out the 2 and the 7 if you wanted to, and which would leave you with 1 plus 1 plus 2 plus 7 plus 0, which is 11. And we're going to break that apart, 1 plus 1, which is going to give us 2. And again, the 2 does not equal 8. So either way you do it, you're going to get the same answer. It's just quicker if you take out the 9s, which is why it's called casting out 9s. All right, we're going to do part B now. We're going to do this the exact same way. We're just going to do we'll start with the 8,550. We're going to add each digit, which is going to give us 18. All right, and then we're going to break that apart to get a single digit. So the 1 plus 8 is going to equal 9. The 6,888 is going to give us 30. And then we're going to break that apart to 3 plus 0, which is equal to 3. 2,525 is going to be broken apart to 14. We're going to break that down even smaller into 1 plus 4, which equals 5. All right, and then we're going to do 6,029. Break that apart to 17. And then that 17 is going to be broken down into 1 plus 7, which is going to give us 8. So now down at the bottom, we've got 9 plus 3 plus 5 plus 8, which is going to give us 25. Break that down a little bit more. So 2 plus 5 is going to give us 7. Now let's take a look at the total that it says that it's supposed to equal. We've got 23,892. So add the 2 plus 3 plus 9, or 8 plus 9 plus 2, which is going to give us 24. So we're going to add that 2 plus the 4 to give us 6. So our total equals 6 for the what they said it was going to equal. But whenever we added it all up ourselves, we got 7. And 6 and 7 are not the same number, so we're going to say that the math was wrong on this one. And we're going to look over on the right side of the screen to where I've casted out the 9s. So that 8,550, nothing's going to change on that. It's still going to equal 9. And we're going to do that one the exact same way. Same with the 6,888. But if we look at the 2,525, if we do 5, if we do, 5 plus 2 plus 2, that's going to give us 9. So we're just left with 5, which if we look on the left side of the screen where we had the 2,525 to begin with, we came up with the answer of 5. So that's going to be the same on either side that you choose. And the 6,029, we are left with 602, which is going to give us a total of 8. So our total with the casting out 9s is also 7, the same as it was on the other side. For our total that they gave us was 23,892. We're just going to take out that 9. It doesn't even exist. We're going to do 2,382, which is going to give us a total of 6. And again, 6 does not equal 7. So this problem is wrong. All right. This one's a little bit different. So I think we've got the gist of you take out the 9s. So we're gonna stick to the right side of the screen now. So we're looking at 78,362 minus 3,674, which equals 74,678. That's their example problem, okay? So if we take out that, if we take out the 8, if we take out the 7 and the 3 and the 6 and the 2, because 7 plus 2 is going to give us 9, and 3 plus 6 is going to give us 9. We're going to take those out. So all we're stripped down to is 8. And then we're going to look at that 3,674. There's nothing we can take out of that other than we could have done the 3 and the 6 because that equals 9. But we still would have ended up with the answer of 2 on either side that you look at, the left or the right side, with or without the 9. So we've got 8 minus 2, which is going to give us 6. So for their total that they gave us, there's nothing that we can take out of it because none of it's, we don't have 9s or anything that's going to equal to 9 in that number. So we're going to do it the same way as we done before. We're going to do the 7 plus the 4 plus the 6 plus the 7 plus the 8. And we're left with 32. So we want that to be a single digit number again. So we're going to do 3 plus 2, which is going to give us 5. And 5 is not equal to 6. So somewhere in this problem, something was wrong. All right, and now we're going to do the multiplication aspect of casting out nines. We're going to, the problem is 337 times 620, which is going to give us 209,940. So we've got 337. There's nothing we can take out of that that's going to equal 9 or be close to it. So we're going to add 3 plus 3 plus 7, which equals 11. We're going to break that down even further, and 1 plus 1 equals 2. And then we've got 620. So we're going to add 6 plus 2 plus 0 equals 8. And then we're going to multiply those numbers. So we've the 2 times 8 equals 16, and we're going to break that down into 1 plus 6, which is going to give us 7. Okay, and so that was what we got for the question part of it. Now we're going to do the answer part of it, which is 209,940. When you add each of these digits up together, you get 24. And 2 plus 4 is equal to 6. So our answers of 6 and 7, they don't match. So somewhere in this problem, they went wrong. But if we draw our attention to the right side of the screen where we casted out the nines, there's nothing in 337 that we could have taken out that would have been equal to 9. So we're going to do this problem exactly the same as we did on the left-hand side, which we're going to get an answer of 2 of. And then 620, it's the same thing as it was on the other side because there's nothing that we can take out of this number that would equal to 9. Again, we're going to multiply those answers and get 2 times 8 equals 16. Break that down further into 1 plus 6 equals 7, just as before. But the only difference is out of that 209,940, we're going to take out the 9s. So we're left with 2,040. We're going to add those digits up together, and basically we're left with 2 plus 4, which equals 6, which is what we got on the other side as well. And so we know that 6 is not equal to 7. All right, we're going to move on to question 3 now. So in part A, they want to know which rods will measure the 9 rod. So if we look at this chart down here at the bottom, the 9 rod is that light blue one right under the 10. So we're going to think about this in terms of multiplication. So that white cube up top, we're going to use that as our symbol of 1. And the 9 rod, we're going to use that as our symbol of 9. So we've got 1 times 9 gives us 9. And we're going to look at 3 also. And we've got 3 times 3 equals 9. So all the rods that will measure to give you the 9 rod are 1, 3, and 9. Okay. Now we are on part B, and they want to know which rods will measure the 6 rod. So again, just like before, we've got the 1 times the 6 this time, which equals 6, and the 2 block times the 3 block, which is going to give us the 6. So the rods that will measure to give you the 6 rod are 1, 2, 3, and 6. Part C, they want us to use the images that we used before for 9 and 6. And we're going to take a look at these pictures, and do we see anything similar out of both of them? I think it's these 3s right here. So the greatest common divisor, which is going to be the biggest number that is able to divide into both numbers, is going to be 3. Part D, they want to see all rods or trains that will measure the 18 train. So we're going to think about this in the same terms as before. We've got that 1 cube, which is going to be, it's going to represent 1. And we've got the rest of the train, which is 18. So we've got 1 times 18 is 18. And then we've got our 2 rod times our 9 rod, which is going to give us 18 as well. And our 3 rod times our 6 rod, which is also going to give us 18. So the numbers that are going to give us 18 are going to be 1, 2, 3, 6, 9, and 18. Part F, demonstrate how you might use these colored rods to demonstrate the notion of greatest common divisor to children. So I'm going to just use a smaller number than we did before. So we're going to start with 4. You know, you're going to do 1 times 4 is 4. And then 2 times 2 is also 4. That's it for our 4 category. And out of the 6, we're going to do 1 times 6 is 6. And 2 times 3 is 6. And looking at these blocks, you're going to say, now what is the one closest to the bottom that is on each side? Which one is the same on both sides? And a child's going to say, you know, instantly it's the red block. Well, this red block is a representation of 2. So this is a simple way to explain the greatest common divisor to children. Least common multiple for question 4. So we're going to look at this chart, okay? So we're going to start with 48, 25, and 65. So if we can do 2 into all of these numbers, 48 divided by 2 is going to give us 12. And 2 is not divisible into 25, so we're going to write 25 again because it just can't go into it. We're just going to bring it on down, and the same with 65. Now I think we need to do another 2 because 24 is still divisible by 2, but we're trying to keep prime numbers. See, we could have done it by 4, but we want a prime number on the very left side. So we'll do a 2 again, and out of the 24 we're going to get 12, and we're going to bring those next 2 numbers down again. And we're going to do this one more time to give us 6, 25, and 65. And last time with the 2, we've got 3, 25, and 65. So where do we go from here? Okay, so why don't we just go ahead and we're going to make this 3. We're going to be done with this 3, okay, out of the 48. So 3 divided by 3 is going to give us 1 because we want just prime numbers. Okay, and then now 3 is not going to go into 25 at all. Just keep bringing it down, and the 65 as well. Now 5 will go into 25 and 65. So we're just going to keep bringing that 1 down, and then we've got 5 into our 25, and we've got 13 into our 65. All right, let's do 5 again so we can get that 5 into its prime form. So we're going to bring that 1 down, we're going to have another 1 from that 5, and we're going to bring that 13 down because it is not divisible by 5. All right, now that 13 at the very end, we just want it to be in its very prime form, so we're going to pull out 13 on the left side, and we're just going to bring those 1s down, and 13 divided by 13 is going to give us 1. So we are left with 2 times 2 times 2 times 2 times 3 times 5 times 5 times 13 times 1 times 1 times 1. Now we don't have to include the 1s, so we're just going to start out with our smallest number. And we're going to do 2 to the 4th power times 3 to the 1st times 5 to the 2nd times 13 to the 1st. So that's our least common multiples of 48, 25, and 65. All right, let's move on to part B, which is 40, 12, 44, and 363. So we've got this whole chart filled out, and as we can see, we've got on the left-hand side our prime form of 2 times 2 times 2 times 5 times 3 times 11 times 11. At the bottom, we've got 4 1s, so we got times 1 times 1 times 1 times 1, which we don't have to use those 1s when we're writing this out. So we've got 2 to the 3rd power times 5 to the 1st power times 3 to the 1st power times 11 to the 2nd power. So that is going to be our least common multiples of 40, 12, 44, and 363. And part C, we're looking for the least common multiple of 250, 28, 44, and 110. So I've got this chart filled out right here for us. And so we ended up with 2 times 2 times 5 times 5 times 11 times 5 times 1 times 1 times 1. Again, we don't have to mention the ones when we are talking about this, so we're going to do 2 to the second because there are 2 2s, 5 to the third because there are 5 3s, and 11 to the first because there's only one 11. That is the least common multiples of 250, 28, 44, and 110. We're going to move on to question 5, and I labeled this section revolution because we are talking about in a machine, a gear with 48 teeth, it's engaged with a gear with 84 teeth. A and B are on the small and large gears, respectively, in contact as shown. They want us to demonstrate how many more revolutions the small gear will have to make before A and B are in the exact same position again. So what we're going to do for this is we're going to take that smaller number, that 48, and we're going to add 48 to it 7 times, because this is the first time that we're going to get the same number for 48 and for 84. So we've got 48, 96, 144, 192, 240, 288, and 336. It only took us 4 times with the 84, but it took the little one 7 times because it's smaller and it's going to turn more than the larger one. So in 7 turns of the small one, they'll be in the exact same position as they are now. All right, we're going to move on to this magic square. So here are the rules for the magic square. It's going to make it so much easier when solving them. We're going to start with number 1. It says start with the top center. So where this yellow dot is, that's where you're going to try to start in every magic square. And then step 2 is wherever you are in the square, just try to go to the top right. The whole time, that's what you're going to try to do, is go to that top right. All right, and then if you can't go to the top right, like I've shown in that first arrow, like there's not a box there, then you're just going to jump down to that last row. And if you ever get stuck and there's a number on the top left, just go down and keep moving right. All right, so let's start with the first one. We were given a 0 in the left-hand corner and a negative 1 in the middle of the right-hand column. So we're going to start in the top center with a -7, and we're going to work our way down. All right, and then so we're just going to slowly work our way to that top right corner. So we've got -6, and we've got -5 here, -4 there, -3, -2. Well, we've already got the -1 in here and the 0. So next is going to be our +1. So at every row, every column, and every diagonal, we want them all to equal the exact same thing. So let's check and see. We've got -9, -9, -9, -9, -9, -9. Diagonally, we've got -9, and the other diagonal, we've got -9. So this all checks. This magic square is complete, and it is correct. All right, so in this one, I needed to make up my own. Well, I thought, well, this should be able to work with any set of numbers, really, as long as it's in descending order of like by ones. So it should work. So we're going to start with the top center and work our way down. So we're going to start with 9, and we're going to use that same pattern as we did before. We've got the 8 in the bottom right-hand corner, the 7 in the middle row, left-hand side, that 6 in the bottom left-hand corner, 5 in the middle, 4 top right-hand corner, and where that -1 was last time, that's where we're putting the 3 this time. Top left-hand corner where the 0 was before, that's where the 2 is going to be, and that 1 is going to be in the same position as last time, and it's going to be at the 1 in the middle column. And I chose these numbers just because it seemed like a simple set of numbers to get the point across accurately. So you got 15 out of that top row, 15 out of the middle row, 15 out of that bottom row. First column is 15. Second column is 15. Third column is 15. The diagonal going up is 15. And the diagonal going down equals 15. So this magic square checks out, and it is correct. All right. That is all I have for y'all today. I want to thank you so much for watching, and I'll see y'all during the next teach. Thank you. Bye.